Understanding and OR gates. In this lesson, we are about to learn digital logic gates. Introduction to digital logic gates. The digital logic gate is the basic building code block from which all digital electronic circuits and microprocessor-based systems are constructed from. Basic digital logic gates perform logical operations of and, or, and non-binary numbers. In digital logic design, only two voltage levels or states are allowed, and these states are generally referred to as logic 1 and logic 0, or high and low, or true and false. These two states are represented in Boolean algebra and standard truth tables by the binary digits of 1 and 0, respectively. A good example of a digital state is a simple light switch. The switch can be either on or off, one state or the other, but not at the same time. Then we can summarize the relationship between these various digital states. Simple digital logic gates can be made by combining transistors, diodes, and resistors. A simple example of a diode-resistor logic, DRL, and gate, and a diode-transistor logic, DTL, NAND gate. This table summarizes the key properties of different logic gates. The table has these rows. Name, the name of the logic gate, not, and, NAND, or, NOR, XOR, XNOR. Algebraic expression, the logical expression representing the gate's function. For example, A and B is written as AB or AB. Symbol, the standard circuit symbol for each gate. Truth table, a table showing all possible input combinations, A and B, and the corresponding output X for each gate. Let's briefly explain each gate. Now let's discuss each logic gate. NOT inverter takes one input, A, and outputs the opposite. If A is 0, the output is 1, and vice versa. And outputs 1 only if both inputs, A and B, are 1. Otherwise, the output is 0. NAND, not, and the opposite of AND. Output 0 only if both inputs are 1. Otherwise, the output is 1. Or, outputs 1 if at least one input, A or B, is 1. Outputs 0 only if both inputs are 0. NOR, not or, the opposite of OR. Outputs 1 only if both inputs are 0. Otherwise, the output is 0. XOR, exclusive or outputs 1 if the inputs, A and B, are different. One is 0 and the other is 1. Output 0 if the inputs are the same, both 0 or both 1. XNOR, exclusive NOR, the opposite of XOR. Outputs 1 if the inputs are the same. Outputs 0 if the inputs are different. Here is a list of common integrated circuit IC packages containing various logic gates and digital components. It includes standard gate packages like quad NAND, NOR, AND, OR, and XOR gates, as well as a hex inverter. More complex components listed are Schmitt triggers, both inverting in NAND, multi-input and in NOR gates, flip-flops, JK and D types, latches, counters, binary and Johnson-Decade, adders, 4-bit and 8-bit, shift registers, a 7-segment decoder, and an 8-port I2C expander. The accompanying image visually represents these IC packages, likely showing their physical appearance and arrangement. In short, the slide introduces a range of digital logic ICs, from basic gates to more complex functional blocks. Simulation. Please follow the circuit diagrams and build circuits with such as within and gate and or gate ICs respectively.